Relations. So we have already come across that thing in class 11th earlier, that when A is any set which is, say, 1 comma 3 comma 4, anything, just a set taken, and a set B, say 2 3 4, whatever, and all the elements that come in A into B, all the ordered pairs like 1 comma 2, 1 comma 3, 1 comma 4, 2 comma, this order pair is this 3 comma 2, 3 comma 3, 3 comma 4, 4 comma 2, 4 comma 3, 4 comma 4, 5 comma 2, 5 comma 3, 5 comma 4. Fine. So it will go on and we'll get 5 comma 4 as the last element, when we do Cartesian product of two sets. So any set R containing these elements, like if R is a subset of A into B, then R is a relation from A into B. So that's what a relation was. But now we have type of relation. So we have to understand three types, properties. We have to understand three properties here. Okay. So properties associated to relation, we have symmetric, so basically what we are studying today, uh, we need to discuss the properties of relations. So we have some properties. One is called reflexive property. What happens in this, that whatever is the statement has to be true for itself. So if I say, for example, let's take one statement. Let's take one property, that line L1 is parallel to line L2. Suppose I take this, then every line is parallel to itself. So that's reflexive. So A related to A is true. Fine. If I say perpendicular to, then obviously any line cannot be perpendicular to itself. So in that case, it is not reflexive. Symmetric. Symmetric property, if A is related to B, should imply that B is related to A. Okay. So what happens if I say L1 is parallel to line L2, then L2 is also parallel to L1. So obviously you see that A related to B implies that B is also related to A. Third property is transitive property. Transitive property. So transitive property is if A is related to B and B is related to some C, that should imply that A is related to C. Okay, so if I say L1 is parallel to L2 and L2 is parallel to some line L3, then obviously you know L1 is parallel to L3 as well. So A related to B, B related to C implies that A is related to C. Hence transitive. If all these three properties holds true, then any relation is such that its equivalence relation. Equivalence relation. Okay, so for equivalence relation, what we understood? It should be reflexive, true to itself, true for itself, symmetric, A related to B, then should imply B related to A, and transitive, which is, you know. So if all three are true, then the relation is said to be equivalence relation. Okay. Though it's very easy to understand through these small examples, but when you see the question, they are not that simple. You know, they won't ask you that L1 is parallel to L2. There are more to it. Huh? So let me explain that. What happens? Like suppose I have generally it will come in the form of points. So if I have 1, 2, 3, 4, these kind of things, and they'll say a relation is from A to A, A into A. So we have all the ordered pairs 1 comma 1, 1 comma 2, 1 comma 3 with itself only, and all. Now, you know, if 1 comma 1, if 1 comma 1, 2 comma 2, 3 comma 3 and 4 comma 4, all the elements are present in the given set, in the given relation. All these 1, 1, 2, 2 same elements, a comma a, x comma x format, then it is reflexive. This part isn't clear to many that you know we take examples of perpendicular, parallel, congruency, similar. Those are very simple things. But when it comes to points, we don't know how to tackle it. So I am clearing that part. If you have points 1 comma 2 and 2 comma 1 is also present there for all pairs, you know. If I have 4 comma 1 and even 1 comma 4 is present, all like that, all the points, then it is symmetric. And for transitive, if 1 comma 2 is there and 2 comma 3 is any other point, then we should have 1 comma 3 as well. Any such combination, A comma B, okay, and B comma C, then I should have A comma C also in the given set for all elements. Then only it is transitive. Once all three conditions are satisfied, then the given relation is equivalence relation. Alright. So let's see some questions. Like let R be a relation in a set N given by A comma B is such that A is equals to B minus 2 and B is greater than 6. Whether the relation is reflexive or not, justify your answer. Now any point taken such that B is more than 6, if B is more than 6, then automatically you see it's given that A is equals to B minus 2 and B is more than 6. So B is A plus 2 and B is more than 6. So A should be more than 4. Okay. So for all the elements more than 4, say 5, 6, 7 and so on, when you do A into A, we get all the elements, but we have to maintain, you know, that this relation, B minus 2 comma B will be the point always. So clearly B minus 2 can never be equal to B. So you cannot have any point in the form of, so we can write for all A comma B belonging to natural number, A is not equal to A plus 2. Therefore, relation is not reflexive. Getting me? Like we cannot have points, no? Like if I take a point 5, then if I write 5 here, no, then I have to write 7 here. 6, 8. So it's increment of 2 here, So you cannot have any element which is in the form of 5 comma 5 or something. Okay. That's why this relation is not reflexive. Show that the relation R in the set N given by A comma B, A is divisible by B. Now A is divisible by B means A by B for all A comma B. It is such that A by B is something like say K1 or something. So A is always BK1. So A upon A for A related to A is 1, hence divisible. So it's reflexive. Then symmetric. If A by B is K1, then clearly B by A is not divisible obviously. It's 1 by K1. Okay. So is not symmetric. Not symmetric. However, if I have A by B equals to K1 and B by C equals to K2, then I have to find out what is A by C. So let's multiply them. A by B into B by C results in K1 into K2 and B cancels. So you get A by C as a new constant K. Therefore, if A is divisible by B and B is divisible by C, then A is divisible by C also. So it's transitive. Hence, solves the purpose because we have to show that it's reflexive, transitive but not symmetric. Clear? So rest of the sums you try. I'll be helping you in the class directly. Okay.